The very first page is vocabulary, parts of a polynomial. Okay. Mine is color-coded. I know yours is not, but still, it has the labels. Coefficient. A coefficient is in front of a letter. So anything in front of a letter is a coefficient. Exponent, you guys know exponent. If it doesn't have a letter, if it does not have a letter, it's called a constant. So in this case, -2 is a constant. Okay? Phones away. Turn them upside down. Oh, yeah, sure. Okay. There you go. You're welcome. Okay. This guy here has got 3 terms. The first term is 4x to the third power. The second term is 5x squared. And the last term is -2. It's called a trinomial. It's got 3 terms. Okay. The leading term is the guy in front. It's in standard form right now because you have the biggest power, next biggest power, no power. That's in standard form, okay? So the guy in front is called the leading term. 4, it's not marked on here, but still important because they're going to ask us, is the leading coefficient. Four is the leading coefficient. Even though 5's a coefficient, it's not leading though, because it's not in first, it's not in front. Leading coefficient means you're in front and you're a coefficient. Okay? The degree, this is a third degree. Degree is 3 because it's the biggest power, right? The biggest power is 3. Okay, so if the degree is 0, it's called a constant. Means it doesn't have a power. Constants stay the same. It's constant. It never changes. If it's a first power, if 1 is the degree, it's called linear. Chapter 1, we talked about constants and linears. Everything we looked at constant and linear things. Chapter 2, we looked at degrees of 2. They're called quadratics. That was the name of your test. Quadratic. Right? So quadratic was when it has a degree of 2. If it has a degree of 3, it's called a cubic. This guy right here, this guy in front of you, the one we were looking at, this is a cubic because the biggest power is 3. Okay. 4 is quartic, quart with an IC at the end. Quartic, if it has a 4th power. And then the last one is the one with the biggest ones we're going to look at is called quintic. 5th power. So the first chapter, we looked at 0 degree and 1 degree, linear. The second chapter, the chapter we just finished, the one you just took the test on, we did quadratics. This chapter, we're going to talk about cubics, quartics, and quintics. So we're just raising the degrees. We're going up in degrees. Okay? Okay, so the bottom is a matching.
Want to take pictures?
Okay? All right. Okay, so now these are matching. There's 7 of them. They match in here. There's 7 spots open. Okay? So we have to figure out which one goes where. So let's look at A. A is -2x minus 7. Which one does that fit in? Is it a coefficient? Is -2x minus 7 a coefficient? No. Is it a leading coefficient? Well, if it wasn't a coefficient, it's not going to be a leading coefficient. Is it a constant? Well, -7 is. right? But negative 2x isn't. Monomial means one term. Binomial means two terms. Trinomial means three terms. Polynomial means more than that. So letter A, which one would letter A fit into? A binomial, yeah, it's got two terms, right? It's got two terms. So it's a binomial. So letter A goes in there. Not going to use that one anymore. Letter B, it's got one term. Monomial, yep, monomial. Letter C has got four terms. So it's not a trinomial. That one's going to be a polynomial. More than many terms. D is a trinomial. It's like the one on the top of the page. Trinomial, D. Okay. The 7 in 7x plus 2. What is the 7 called in a 7x plus 2? It's a leading coefficient. Good. It's in front and it's a coefficient. So that's a leading coefficient. Not just a coefficient, it's a leading. The negative 5 in 8x to the second power minus 5x plus 3. Negative 5 is also a coefficient because it's in front of x, but it's not leading. It's just a regular coefficient. And then the last one is G. 9. 9 doesn't have a letter. Doesn't have an x, doesn't have a letter. So it's called a constant. Okay? All right, so let's go to the back now. The back is more of less vocabulary, more of the math stuff. So number 1. Perform the operation. Operations in math are adding, subtracting, multiplying, and dividing. There's 4 of them. So use whatever one you got to use. Well, we've seen problems like this before. What do you actually saw them on last chapter? What do you think the first thing I'm going to do is? Yeah, distribute, right? Distribute, multiply. That's what you're going to do. There's a 1 in front of here. There's a negative 1 in front of here. Distribute. That's exactly what you're going to do. Multiply. So 1 times negative 3x squared is negative 3x squared. 1 times negative 9x is negative 9x. 1 times positive 5 is positive 5. The next one I have to multiply times negative 1. So it's positive 2x squared, positive 4x, minus 7. No more parentheses. Now what do you think I'm going to do now? Combine like terms. We've done that before. X squareds first. So you're going to get negative 1x squared when I combine those two. X. Combine those two, you get negative 5x. And then the last one are the constants. No more like terms. You're done. Simplified. Okay? We've done that part before. Number 2, what do you think I'm going to do to simplify here? Distribute. Distribute what's in front with what's inside. So I have a 1x, it's a 1x squared, right? So 1 times negative 10 is negative 10. I had 2x powers. I'm multiplying times another 2x powers. How many powers do I have total? 4. Then 1 times 1 is 1x squared. Those aren't like terms, so I'm done. All right, not too bad. Number 3. Am I going to do on number 3 what I did on number 1? Some of you have seen this because we had one kind of like this with eyes, and you try to distribute. This one you can't distribute because there's nothing in the middle. If there was a minus or a plus in the middle here, you could distribute and do that, yeah, like we did on number 1, but there's nothing there. It means multiplication. So we're going to do what we did last chapter. I'm going to set up a multiplication box. So for this guy and for this guy, I'm going to create a box that fits all of this stuff in there. Well, the yellow has 2 terms. So I need 2 terms here. The orange has 3 terms. So I need this side to have 3 sides. Because I'm multiplying. So the yellow had a 3x and a minus 1. The orange had a 3x squared, a positive 4x, and a positive 6. Now I'm going to multiply, multiplication table. We've done this before with the eyes. It's the same thing. So I have 3 times 3 makes 9. I have x squared times x. I have 3 x's, x to the third. Okay. The next one. I have 3 times negative 1, which is negative 3, squared. Because negative 1 didn't have any powers. Okay, next spot. 3 times 4 is 12. Each one of them comes with their own power of x, so together they make squared. Then I go 4 times negative 1 is negative 4. Negative 1 doesn't have an x, but 4 does, so it makes negative 4x. Last row. 8 times 3 is 18 with the x that 3 brought. And then the last one is 6 times negative 1, which is just negative 6. No powers of x, because neither of them had a power.
So if yellow had another number,
Mhm.
you would just do the same thing, but add more squares?
Yeah. Build the box to whatever you need. Build the box to whatever you need. Sometimes this size box will work. Sometimes you need a bigger box. Sometimes you need a smaller one. Build it however you need it, yeah. Okay? So last thing. Start with the biggest power inside the box. That's 3, right? Is there any other x to the thirds? Nope. So we can't combine anything with 9x to the third, so we're going to write 9x to the third. The next one is squared. I have 2 things that are squared. So I get positive 9x squared, because 12 plus a negative 3 is positive 9. Next one is x. I got 2 things with an x. And then negative 6 is the only one that has no x's, so that one can't combine. I'm done. That's as far as I can go. So yeah, when you're multiplying polynomials times polynomials, or binomials times trinomials, or binomials times binomials, you got to build a box. What size box? It just depends on what size polynomials you have. So look at number 4. What size is my multiplication box going to need to be? 3 by 3. Yep, 3 by 3. So I'm going to need to build a 3 by 3 for the next one. First one's got 3 terms, so that's going to need 3. Next guy's got 3 terms, so that one's going to need 3. So I'm going to need a 3 by 3. Okay. No, yeah. So like, yeah, great question. Does it matter if it has 3 rows and 2 columns or 2 columns and 3 rows? No. So if I were to like turn it this way, this guy would have been on top, that guy would have been on the side, right? Yeah. Because you're multiplying, order doesn't matter. Okay. All right, so let's go back. So yeah, does it matter which one's on top and which one's on the side? Nope, because they both have 3 terms. 4x squared plus 7x plus 3, x squared minus 3x plus 4. And you're just going to multiply. Multiply to fill up all of the spots. So the first one would be 4x to the 4th power. Then 7x to the 3rd power. Then 3x squared. The next row would be negative 12x to the 3rd power. Then negative 21x squared. Then negative 9x. Last row, 16x squared, because I multiply this guy times this guy. Now this guy times this guy is going to be 28x. And then the last one's plus 12. Start with the biggest power. 4 is the biggest power. I only have one thing that has x to the 4th, so that guy can't be combined. I have 2 things with x to the 3rd. I can combine those to make negative 5x to the 3rd. I have 3 things that are x squared. Negative 2x squared, I think. And then I have 2 things that I have just x or x to the 1st power. Positive 19x. And then I just have positive 12 is the only one is the only constant. Done. So your answer has 5 terms. 4x to the 4th, negative 5x to the 3rd, negative 2x squared, positive 19x, positive 12x. Okay. All right, so the last one mixes everything we've done so far. So it kind of mixes example number 1 with example number 2, with example number 3, with example number 4. It's kind of a mixture of everything. For that reason, these are the ones that you see a lot on tests and quizzes. Number 5, because it's kind of like one problem that exemplifies everything. Okay. Simplify. So anytime you see the word simplify, you always follow PEMDAS, right? PEMDAS, parentheses, exponents, or gems, depends on how you were taught. So the first thing is parentheses, right? Inside the parentheses, can I add up x plus 4 to make 4x? No. So there's nothing to do inside the parentheses, okay? What was the next one? Exponent, right? I do have an exponent. Squared. What is being squared? The whole thing, right? This whole thing is being squared. What does squared mean again? Times itself. So I have to do that first. How am I going to do that? Watch. I'm going to take a little detour over here. How do I multiply x plus 4 times itself? I use a multiplication box. A 2 by 2 because there's x plus 4 and x plus 4. There's only binomial times a binomial. So I get x squared plus 4x plus another 4x plus 16. Combine like terms. I get x squared plus 8x plus 16. That's what it is. That's what it is when you multiply it. It's the same thing. So I'm going to replace it now. I'm going to take this answer that I got, and I'm going to replace it in there. Everything else stays the same. So that's how this became that. I just took what it was and replaced it because these are the same things. How do I get rid of parentheses? Yeah. Yeah, exactly. How do I get rid of parentheses? Distribute, right? So there's a 1 in front of there. I can distribute. And there's a negative 4 in front of there that I can distribute, right? So I get 1x squared plus 8x plus 16. And then minus 4x minus 16 plus 6 when I distribute the other guy. No more parentheses. Last step. Combine like terms. 8x, negative 4x, (16) minus 16 plus 6. You're done. Okay. All right, so I'm going to give you one to do extra in your notes. It's going to be like this. It's going to be similar to this because these are the ones that you're more likely to see. On tests and quizzes, they always throw these in because it has a little bit of everything. You had to make a table. You had to distribute. You had to combine like terms. Okay. All right, so here we go. I'll pass out the tape right now. Number 6. So number 6 on page 17. This one I'll actually do with you because it's a little different. So I'll do this one with you. Okay. Here's a question. Can I distribute the 3 in front to x plus 4? No, yeah, the answer is no. I get a lot of people who try to do that. The reason you can't do that is because of this power here. Anytime there's a power other than 1, you can't distribute. I have to take care of that power first before I can distribute. Well, how do I do that? The same way you did it earlier today or 5 minutes ago. I'm going to take this guy, and I'm going to actually multiply it. So yeah, so it's going to be the same thing as we did on the last problem. It's just coincidence. It won't always be x plus 4. So you get x squared plus 4x plus 4x plus 16, and then we combine like terms. And then we replace. Okay. Now there's no more squared. Now can I distribute? Yes. Now you can distribute since there's no more squared on the outside. The parentheses don't have any squareds anymore. So we get 3x squared plus 24x plus 48. That's the first parentheses. Second parentheses, negative 4x minus 16, and then you get the negative 5 that's out there. No more parentheses. Last step, combine like terms. Positive 24x, negative 4x, positive 20x when I combine them. Positive 48 minus 16 minus 5. 32 minus 5 is 27. Positive 27. Done. So the main thing is do the powers first, then bring it back and distribute later. Distribute second. Okay? All right, so tape those in your notes. On Monday, we'll do some practice on that. We'll do practice 12, 13, whatever it is, and then we'll go from there.